All right. So I guess the light's just going to be weird. Maybe. That's a maybe, I don't know if that's better or not. Okay, so we've got secant x times tangent squared x equals 9 secant x. And the fun thing is that we've got two functions and one of them is squared. So this is definitely not linear. The first step is always to get everything to the same side of the equal sign. So we're going to move this 9 secant x to the left. So we'll have secant x times tangent squared x minus 9 secant x equals 0. And we still want to think of this as factoring, regular equation. So we're going to make two replacements. We're going to let y equal secant x, and let's let u equal tangent x, because that will enable us to see how to factor more easily. So then this equation above becomes y u squared minus 9y equals 0. And if you solve this equation, what would you do first if you wanted to solve it? Would you maybe factor? Okay, let's try factoring. So we've got a y in common. I'm just going to factor the y out. Now we've got u squared minus 9 equals 0. And u squared 9, I know how to factor that. That's the difference of two squares. So I'm going to factor u minus 3, u plus 3 equals 0. And now I know that I've got the 0 property law that says that if the product of things equals 0, then at least one of them must be 0. So I'm going to set y equal to 0, u minus 3 equal to 0, and u plus 3 equal to 0, and solve for the variables. Well, y equals 0, that's done. U minus 3 equals 0, we get u equals 3, and u plus 3 equals 0, we get u equals negative 3. And now we're going to go back. We had y with secant x, so now we've got secant x equals 0. U was tangent, so we've got tangent x equals 3, and tangent x equals negative 3. And now we can see, do we have solutions? Do we not? Do they make sense? And secant x equals 0. Well, secant is the reciprocal of cosine. Where is cosine 0 between 0 and 2 pi? Yeah, cosine is 0. So let's see. We know that cosine is the reciprocal of secant, and cosine is 0 when x is pi over 2 or when x is 3 pi over 2. But let's think about this. When cosine is 0, 1 over 0 would be the secant. Is the secant going to be 0 ever? That's right. No. This leads to no solutions. And now we've got tangent x equals 3, tangent x equals -3. And that is possible. So to write the solutions for those, we get to draw triangles. So tangent is positive in the first and, oh, this isn't using inverses. So just the first quadrant, and tangent x is negative only in the fourth quadrant because we're looking at functions that might be invertible. So let's draw a triangle in the first quadrant. And tangent is opposite over adjacent. So opposite over adjacent. To find the hypotenuse, we're just going to use the Pythagorean theorem. And so we've got 1 squared plus 3 squared is c squared. That's 10 is c squared. Take the square roots. So c is plus or minus 10. I know that c has to be positive. So here c is the square root of 10 . Wait, I'm thinking slowly these right now. So to find x, we just need to use a calculator. So let's see. I'm going to go to my phone calculator and I'm going to turn it sideways, and that gives me the scientific calculator. I'm going to tap in 3, and then I'm going to use the second key to get the inverses, because I don't want the tangent of x, I want the inverse of x. And we get 71.56, and that's in degrees. I want it in radians, so let's do that again. 3 second, and now that's radians. So we get that x is equal to 1.25 radians. And let's go ahead and give the degree value as well. 71.6 degrees. Usually with radians, you do 2 decimal places, with degrees 1. And then we should get similar values for the -3. So let's see. We get 3, and I'm going to tap the plus minus to get the negative. And inverse tangent, I get exactly the same value, but negative. So it's in the fourth quadrant, just like we thought. So x is negative 71.6 degrees. And let's do that in radians. 3 negative inverse 10. And we get the same thing, negative 1.25. And let's use the calculator to see that secant x equals 0 has no solutions. So let's type in 0 and second, so that we have the inverse functions. And Oh, we need a reciprocal. So let's find the inverse tangent, cosine, and then let's find the reciprocal of it. Wait, no, I'm backward. I'm so backward. Yeah, secant x is 0, never. So how can I show you that on the calculator? It's 1 over cosine x. Okay, that's how. So let's do 1 divided by 0 inverse, no, not u. Okay. 1 divided by inverse cosine of 0. Oh, I'll have to figure it out later. I think my brain is just dead right now. So, but yes, so we only get the solutions for the tangent. The try thises I do want y'all to do, and I'll give you a space to turn those in after the lecture today. All right, solving right triangles. You might think to yourself, well, we've done that. We've solved right triangles. We haven't really solved triangles at all. So first of all, we are going to have a new labeling convention. This is super important. From now on, an angle is going to have a capital letter and a side is going to have a lowercase letter, and the angle and the side are going to be opposite. So angle A is opposite side A. Angle B is opposite side B, and angle C is opposite side C. And for right triangles, angle C will be the right triangle. To solve a triangle means to find all the sides and all the angles. So solving means find every side and every angle. And what we're going to do is put that information in a table. So even the information you were given, like for this triangle, we were given that the measure of B was 52 degrees and the side A was 11. But we're still going to include that in our information. And let me go ahead and explain this. This M, angle B, says the measure of angle B. So we're going to use this notation from now on. And right now we're looking at right triangles, but we're about to look at triangles that don't have right angles or don't necessarily have right angles. So let's solve a right triangle if we only know let's see. I'm going to go ahead and label everything. So I know that C has to be the right angle for right now. B is above, A is to the left, and then side A is opposite angle A, side B is opposite angle B, and side C is opposite the right angle C. And we were told that angle B was 52 degrees and that side A is 11. So how can we find all the other information? We do know that C is 90 degrees. Can we find angle A? Yeah, right. If we know B is 52 and C is 90, we know the whole thing makes 180, and we can subtract off the 90. So we know that A plus B is 90. We know A plus B is 90 degrees because this is a right triangle. So let's see, B is 52. And so we can subtract 52. Oh, so A is equal to 38 degrees. We know one of the sides, but we can't use the Pythagorean theorem yet. We don't have another side yet. So how could we find another side if we have a right triangle? So I'm going to say something. Right triangles means that trig functions still work. So how can we use the fact that we know all the angles and we know this side A to find another side? We can say that, let's see, the sine of A, that's opposite over hypotenuse. And the opposite is A. The hypotenuse is C. So A is 11. And C is, we don't know C. We do know A. So the sine of A is 11 over C. Let's go ahead and solve this little equation for C before we fill in the sine of A. So I'm going to multiply both sides by C and divide both sides by the sine A. And we get that C is equal to 11 divided by the sine of A. Whoa, what's the sine of A? Oh, okay. So A is 38 degrees. I'm just going to use my calculator. So this stuff going forward, we'll use calculators quite a bit. And mine tells me when I'm in radian mode, which I don't want to be in. There's this button at the bottom. And if you have an Android, it should be fairly similar. Okay, so I'm going to type in 38, and here's sine. So the sine of 38 degrees is I'm going to use 4 decimal places. So it's 6, 1, 5, and this last 6 is next to a 6, so it's going to bump up to 7. So the convention, sides get a decimal place of 1, angles get a decimal place of 1, sines, all trig functions are written up to 4 decimal places. So let's see, that's weird. So 11 divided by 0.6157. So 11 divided by 6157. So A, oh no, this is C. C is equal to 17 point, and I'm going to round to 1 decimal place because this is a sign. So 0.9. So now I know C, 17.9. And let's find B 2 different ways. Let's find B using the Pythagorean theorem and then also using trig. So let's see. Using the Pythagorean theorem, we know that A squared plus B squared is C squared. We know that A is 11. And we just said that C was 17.9. We're going to subtract 121 to get B squared. So let's see. 17.9 squared minus 121. Oops. 17.9 squared minus 121. Now, okay, so B squared is 199.4, and I'm going to take the square root of that, and I get that B, and I'm going to use 1 decimal place. So B is approximately 14.1. So we've got a value for B, 14.1, and let's find B one other way. Let's find B using the sine of 52, because we know that the sine of 52 degrees, well, sine is always opposite over hypotenuse. We know the hypotenuse, and we know the sine of 52. The opposite of 52 is B. So we've got B over 17.9. And I'm going to multiply both sides by 17.9. To get another value of B, and let's see how close we are. So we have 52 times 17.9, and we get 14.1. Isn't that cool? We get the same thing. So these are always fun. And you can see now, perhaps, why we always list all the information in a box at the end. So we've got the sides. A is 11. B is 14.1. C is 17.9. Angle A is 38. Angle B is 52 degrees. Oh, yeah, okay. And the measure of angle C is 90. It may seem silly to list all this out, even though you know some of the information already, but doing this for every problem will make your life so much happier. Okay. Let's do another one. The try this questions have answers, all the answers at the end of the notes. Let me just show you really quickly. Wait, all right, I missed the thing. Oh, not for these notes. Sorry, I'm gonna put it in, but I don't have it yet. So I want y'all to do the try this questions later. Okay. What if we know that A is 10 and B is 12. And we know we're having a right angle. But we don't know any other angles. So we've got angle A, angle B, angle C is 90 degrees. Little a is opposite. Big A, little b is opposite. Big B and C is opposite. Big C, and we know that A is 10 and B is 12. We can use the Pythagorean theorem to find C because we have a right triangle. So we know that C squared is going to be 10 squared plus 12 squared. So 100 plus 144, that's 244. And we can put plus minus signs in front of the square root here, but we're in a physical triangle. We're not on the coordinate plane right now. So all of the measures are going to be positive. So let's use our handy dandy phone. 244 square root. And I get 15.6. Well, I don't know any angles except the right angle. Let's see if we can use trig to find some of these angles. So I know that, let's see, C is 15.6. Oh, we did sine last time, and cosine feels left out. So let's see, the cosine of A is opposite over hypotenuse, and we know both of those sides. We know the opposite is 10, the hypotenuse is 15.6. So cosine of A is that number. We can take the inverse cosine of both sides, and inverse cosine of cosine cancels because A is positive. So we get A equals, and we have 10 divided by 15.6. And we want to take the inverse cosine of that. I don't have a radian thing. If I press radian, I see a radian thing. So I want to take that away. And I want to press second inverse cosine. I did something else. So I've got 10 divided by 15.6 inverse cosine, and we get 48.2. So A is approximately 48.2. And let's find angle B using trig and also using the sum of the angles. So we know that, let's do tangent for B. We know that the tangent of B, well, let's see, tangent is opposite over adjacent. And we're looking at this from the point of view of angle B. So opposite would be side B. Adjacent would be side A. So let's see, that's 12 divided by 10 is the tangent of B. And we're going to take the inverse tangent of both sides to get B by itself. So inverse tan there. inverse tan there. So we get that B is equal to the inverse tangent, and that's 1.2, right? 12 divided by 10. Yes, it's 1.2. All right. So I know that the radian thing is not there. So I'm in degrees. I'm going to press second inverse tan. And I get 50.1. So B is approximately 50.1 degrees. And let's add the angles and see if we get 180. So 50.1 degrees. We said that A was 48.2 degrees. So let's see. The measure of angle A plus the measure of angle B plus the measure of angle C. Now let's see. Measure of angle A, that's 48.2. The measure of angle B was 50.1. Oh, it's close. Plus 90. Let's just see what we get. 48.2. Yeah. 48.2 plus 50.1 plus 90. We get 188.
On the paper you did, your measure of angle A is 39.8.
Oh, bless your heart. Thank you, thank you, thank you. I don't know. So 39.8. 39. The measure of angle A is 39.8. Is that right?
Yes.
Thank you so much. What would I do without you? Okay, now we get some better values here. So we have 39.8 plus 50.1 plus 90. 39.8 plus 50.1 plus 90. And we're very close. 179.9. And that's close enough. So we're very happy. And like I was saying before, you want to put the answers in a table. So we have the measure of angle A, and the measure of angle B, the measure of angle C, little a, little b, little c. So let's see, measure of angle A is 39.8. Little a, we got, oh, we started with 10. Measure of angle B was 50.1. Measure of angle C is 90 degrees. Little c was 15.6. But having the information there in a box makes it super, super easy for you to read it later and find the information. Thanks again, Lynette.
You're welcome.
Okay. Look where we were. Oh, I see. I see what I did. And you can see that we got the same values. So now we're going to look at the main reason you do these right triangle problems is applications, because there are so many. The angle of elevation, if you look at something, here's your eye line. The angle of elevation is the angle above your eye line. The angle of depression is the angle below your eye line. Sometimes they'll just tell you the angle of elevation, and that will be based with a horizontal, which we assume to be the earth or something. So they have to tell you what this horizontal measure is so that you know where you're measuring above or below. So to do any of these applications, you want to sketch the situation, label all the sides and angles of the right triangle, and find all the missing ones using the methods that we have. And then finally, answer the original question. So let's look at this. We have a child flying a kite on a windy day. He holds the spool of string at a height of 4 feet above the ground and notes that the string makes an angle of 42 degrees from the horizontal. He loves math. He has 120 feet of string out, and the sag is negligible, so it's pretty taut. We want to find the height of the string to the nearest foot, and we want to find out how far away the kite is from the child horizontally. So in other words, we want to find B, which is the horizontal distance, and A, which is the height with respect to the child. Let's also find the height from the ground. So I've got a triangle. $42 degrees, 90 degrees, 120 feet. We can find angle B easily. So how do we find angle B easily? Yeah, we know the sum of the angles is 180. So angle B is going to be 90 degrees minus the measure of angle A. And that's because we've got a 90-degree angle. So we have 90 degrees minus 42 degrees, and that's 8, 48. So the measure of angle B is 48 degrees. Now we can easily find a and little b using trig. So we know that, let's start with A. We know that the sine of A is opposite over hypotenuse. The opposite with respect to A is little a. Hypotenuse is always C. And we know that A is 42 degrees. I can multiply both sides by 120. To get little a alone. And it's really helpful to do as much math as you can before you start plugging in big numbers like the sine of 42. So we get that little a is equal to 120 times the sine of angle A, and the sine of angle A. Let's see. Angle A is 42. 42 sine, and oh, I've got that radian thing showing, so take that away. Sine, we get 0.6691. So all trig functions go out to 4 decimal places. The 5th decimal place tells you whether to leave the 1 as it is or round up. 3 is less than 5, so I leave it. And let's see. And I don't want to keep that information in my storage. I want to multiply by the 4 decimal places. So 0.6691 times 120. I get 82.3. And let's see, that is the height with respect to the child. So 82.3.
I think you might have gotten 80.3. I'm not sure.
Okay, let me try it again. Thank you. So we've got 42 sine. Oh, I want to cut it off. So 66.6691 times 120 is 80.2, 80.3. Thank you. Oh, Lynette. 80.3 feet. And then B will be, let's do the cosine of A, because that'll be nice, and cosine gets left out a lot. So we know that the cosine of A is adjacent over hypotenuse, and adjacent with respect to A. So the adjacent with respect to A is little b, hypotenuse is 120, it's always C. And we're going to multiply both sides by 120. So we get that 120 times the cosine of A is equal to little b. And so let's 42, and I don't have the radian thing shown. Cosine, I get 4 at 74314. So I'm going to put in 7431. And I'm not going to leave this number. I'm going to delete it and multiply by the approximation I found. 0.7431 times 120, and I get 89.2. And we've solved the triangle. This important step is answering the original question. So we had several. We wanted to find how far the kite was from the child. Well, it was B away, and B was 89.2 feet. So the kite is 89.2 feet from the child. We wanted to find how high the kite was, and we wanted these to the nearest foot, so we can do some rounding in a second. The height with respect to the child was 80, so we're going to round off. So the height is 80 with respect to the child, 80 feet. How high is the kite with respect to the ground? Well, I know that the child has the kite string 4 feet off the ground. So the height with respect to the ground is 4 plus 80. So 84 feet. And the height, the distance from the child is approximately 89. And lots of times, questions will have rounding like this thing to the nearest foot, because even though the child is super good in math, it's hard to get an accurate angle. So he kind of guessed that the angle was 42. Also, the distance out from the string. He's good at measuring and could tell how much is left, but still, there's so much that we're not knowing for sure that rounding makes sense. Wow, I didn't answer the final question. Okay, so I'll fix that when I go back. Okay. Y'all have this one to do. And let's see. From an eye level of 6 feet, an observer standing 30 feet away from a building sights the bottom of a window. The bottom of the window is at an elevation of 61 degrees. So this height, this angle here is 61 degrees. She sights the top of the window at an elevation of 20.1 degrees. So the whole angle there is 20.1 degrees. And we want to find the height of the window. So we want to find that measure to the nearest 1/10 of a foot. So, wow. Let's see what we have. We have 2 right triangles. I'm going to draw the one that looks like that one first. So we've got 20.1 degrees. And that we're going to call A, little a, C, B. Okay, so we've got, and so it's A we're looking for. We care about angle, side A. We know that C is 90. So we know that we're going to have to find more than just A. Oh, she's 30 feet away. So we know that B is 30 feet. So let's use cosine. Let's use the cosine of A. We know that that's adjacent over opposite over hypotenuse. Oh no, let's use tangent. What am I thinking? Because we need opposite and we've got adjacent. So the tangent of A is opposite over adjacent. And opposite is little a, adjacent is little b. Let's multiply both sides by b. B times the tangent of A is little a. We know B, we know A. So we've got 30 feet times the tangent of 20.1 degrees. And that's going to be approximately side A. So let's see. I don't have the radian thing showing, so that's good. 20.1 tangent. So the tangent of 20.1, and I have to round and then multiply. So it's 0.3659. This is almost 5, but not quite, so we don't round up. And I have to erase that and multiply. So now I've got 0.3659 and I'm multiplying that by 30, and I get 10.977. Ooh, okay. So I get that little a is approximately, let's do 2 decimal places and round at the end. So 10.98 feet. They want the final answer in 1 decimal place. Okay, so now let's look at this smaller triangle. We've got angle A is 6.1 degrees. We still have side B is 30. We still want to find A. And we know that side C is, angle C is 90. So we're going to use tangent again. The tangent of 6.1 degrees is opposite over adjacent. I'm going to multiply both sides by B to solve for A. So B is equal to, let's see, B is equal to, oh no, B times the tangent of 6.1 degrees is equal to A, and now 6.1 tangent. So the tangent of 6.1 degrees is approximately 0.106. And this 5th digit is a 6, so the 8 bumps up to 9. It's really important to use the value that you write down and not the value that's in calculator. So we have 0.1069 times B, which is 30, times 30. We get 3.21. We said we'd round at the end. So where did I write the, oh, yeah, 10.98 feet. And the way that we're going to find the height of the window is by subtracting those two. We have 1A value goes the whole distance. The other A value is just this lower part. So to get this red part, we're just going to subtract the little part from the whole thing. So the height of the window, I guess that's right, will be 10.98 minus 3.21. Let's see. 10.98 minus 3.21. I get 7.77, and I'm going to round that to the first decimal, so 7.8. And that's my answer. Let's see how close it is to what I got on here. I got the same thing. Yay. And here I rounded both times before I did that and got the same answer. So that's great. Okay. Oh, this is good. Airplanes. Everybody loves it. Sort of. Okay. An airplane begins its descent at an average speed of 200 miles per hour at an angle of depression equaling 15 degrees. So that little angle is 15. How did I get this? I'll show you in a second. From the number, find the number of vertical and horizontal miles to the nearest tenth of a mile that the plane will cover in 3 minutes. Okay, so we know that the speed is 200 miles per hour. But the time we care about is 3 minutes. And that the angle of depression is 15 degrees. Okay, so if I draw it this way, you'll see more quickly how we know this inside angle. So we're starting with 15 degrees with respect to the horizontal of the plane. So here's the plane. I can't draw planes. There's the plane. It's going to reduce its angle by 15 degrees. So its angle of depression is 15 degrees with respect to the horizontal line that goes through it. So I'm going to take this line that is the path of the plane and cut two horizontal lines. One of them is the level of the plane, the other is the level of the ground. And we know from early geometry that if you cut two lines by a transversal, the lower angle and the upper angle will be the same. So this has to be 15 degrees. And now we just need to find all the numbers. So, well, this one is weird. We want to find these values in miles to the nearest tenth of a mile, but we're not given the distance it flies. We're just told it's going 200 miles per hour for 3 minutes. So let's see. We've got 200 miles per 1 hour. So the per in the miles per hour, I made it look like a division so that I could figure out how to go from hours to minutes. So let's see. 1 hour. And I know to put hours on the top because I've got hours on the bottom in the beginning. 1 hour is 60 minutes. So if I multiply by 1/60, I can divide hours out and I get miles per minute. So let's see what that is. 200 divided by 60, that's the same as 20 divided by 6. So we've got 20 divided by 6, 3.33 miles per minute. So how far? Oh, he's going, or she, for 3 minutes. So let's multiply this value by 3. So we have 3.33 times 3, 9.99. So this distance, the hypotenuse, is 9.99. And it's miles. because we multiplied by minutes, the minutes are gone. So it's like 3.33 miles per minute, and we multiply by 3 minutes. So the minutes divided out, and we're just left with 9.99 miles. Oh, groovy. So let's see. If I take the sine of 15, I'll get the vertical height. And if I take the cosine of 15, I'll get the horizontal distance. Okay, let's see. So we've got sine of 15 is opposite over hypotenuse. We're going to multiply both sides by 9.99. To get little a, which is our vertical distance. And we have to do the trig part first, round, plug it back in, and then multiply. So we've got 15 sine is 0.2588 2588 times 9.99. So we get that the vertical distance is approximately 2. They said to round to the nearest 10th of a mile, so I'm going to say 10.6 miles. To find the horizontal distance, we're going to take cosine. So I've got 9.99 times the cosine of A will equal little b. And let's see, 15 cosine, 15 degrees is approximately 0.9. Let's see. The fifth digit is a 2, so I don't have to round up that 9. So it's just 0.9659. In the real world, you can use all the digits. But in these problems, especially the ones that you do on ALEKS, if you use all the digits and don't round until the end, you'll get a minor error. Sometimes it'll say don't round until the end, but otherwise you really do want to. So let's see, we've got 0.9659 times 9.99. We get that B, the horizontal distance, is approximately 9.6 miles. And so the last step would be writing down those answers. So, oh, I did do that on the window one. And let's see if I did it on the, so I said, no, I didn't. Oh. So I'll go back and do that. So you really do want to answer the questions at the end, like I did on this one problem and not any of the others. All right. Okay, pitch. We want to find the pitch of the roof to the nearest 10th of a degree if the roof is 6 feet high at the highest point and 15 feet wide. And we have to assume that it's symmetrical, that the height of the roof happens at the middle. Because otherwise you can't do the question. And pitch is always the lower angle, not the upper angle in the big triangle that makes a roof. So we're going to cut this in half. We know that the whole distance was 15 feet. So half of the distance is 7.5 feet. We're looking for this angle, and I'm going to call it A because it's the lower angle. We know that this height is 6 feet. Well, if we know opposite and adjacent, the easiest way to find A, angle A, is using tangent. So the tangent of is 6 over 7.5. Because it's opposite over adjacent. So let's see, what is 6 divided by 7.5? 0.8. So I want to find the inverse tangent. I got that. I know that the tangent of A is 0.8, but I want A. So I have to take the inverse tangent of both sides. All of the angles, everything we're doing right now is positive. We're not in a coordinate axis. So I don't have to worry about the domain of the angle A. It's a positive angle, so inverse tangent of tangent is going to be A. So I have A equals the inverse tangent of 0.8. I make sure that the radian thing is not there. Second, there's the inverse tangent. I get 38. So let's see. The measure of angle A is approximately, I'm going to do several digits and then round once I see again how many. Let's do this time. Let's round to 3 digits when the third digit is a 9. So this 8 next to it says go up. If I go up here, that becomes a 10. So it's 660. I just wanted to show you rounding if you have a 6 there. So let's go back. They wanted the answer to the nearest tenth of a degree. So angle A is approximately 38.7 degrees. And I'm not answering the questions. Oh, that's terrible. So I will go back and do that. Please do that in your work. Take the time to write down a sentence for answering the question. All right, so we've got, oh, here's my bearings. It's really important. It's even if you're not doing engineering, it's really helpful to know bearings. So the bearing from A to B is the degree measure of the acute. Acute is less than 90 of the acute angle formed by the ray AB and the north-south line. So let's see. Here's A. Let's do this. Here's B. Here's the north-south line. So the bearing would be this angle. Yeah. What if we had A and B? Here's the north-south line. The bearing would be that angle. It's always the angle that is less than 90 degrees. Does that make sense? Okay. So to find the bearing, those are so tiny. Let's see if we can. Okay, good. So if that the angle between A and B and the vertical is 42 degrees, then the bearing is going to be 42 degrees. Oh, and I forgot. So you do the direction that you're going. So if we go from B to A, from B to A, we're going down, so south, and we're going west. So the bearing from B would be south 42 degrees west. Oh, thank you.
No problem.
All right. And here we have the bearing from A to B is 74 degrees. And this would be, let's see, we're going up from A to B. So it would be north 74 degrees. And I have to go from A to B, I have to go to the left. And we want to find the bearing from B to A. And what's cool is that always it's going to be reversed. The bearing from B to A will be south 74 degrees east. We have to go down to get to A from B, and we go to the right, which is east. And I think I just deleted that whole question. I don't know why it was there. Okay, so we want to find the following bearings. We want to find 0 to C. A to 0 and 0 to B. And it's not 0, it's the origin, I guess. Oh, I think this must have been the answer for that one. Oh, I'm confused as heck. Okay, doesn't matter. Oh, I bet these are the angles for question 9, which I'm going to get rid of. So here's our image. So we've got, I'm going to go back to the normal view. I think we can dispense with our zooming in. Yeah. Can y'all see that?
Yes, ma'am.
Yes.
Oh, thank you. So we've got, let me see. Oh, no problem, Nat. Okay, good. Oh, those are the answers. So from the origin to C. The origin to C. We're going south, we're going down. So O to C would be, and you would write that as OC with a little arrow because you're looking at a direction, equals, we already know that it's going to be 40 degrees, but it's going to be south, and we're going to the right, so it's to find A to the origin. We're starting at A and going to O. So A to O. We're going down to get from A to O. So that's south. We have 22 degrees. Oh, we have 22 degrees between the horizontal and A, but we need that angle. We need the angle with respect to the vertical that is the smallest, and that is going to be 90 minus 22. So 68 degrees. So it'll be south, 68 degrees. We're going to the left, so that's west. And finally, we want to go from the origin to B. Let's see, O to B. So from the origin to B, oh, and they tell us that the angle from the horizontal to B is 118 degrees. So to get to this angle, I need to subtract 90 from 118. So that because I want the smallest angle between the ray and the vertical. So we've got 118 minus 90. Oh, what am I doing? 11 minus 92. So 28 degrees. So we have OB is, let's see, to go from O to B, we're going up, so north. We said it was 28 degrees, and we're going to the left, which is east, west. Sorry about that. Okay. Let's do one more question here, and then we'll take a short break, and then we'll start looking at the law of sines and the law of cosines. And that's going to be so much fun, really, honestly, so much fun. Okay, so we've got a plane that leaves the airport heading south 32 degrees west at 320 knots. And that means nautical miles per hour. Determine the number of nautical miles south and the number of nautical miles west that the plane travels in 1.2 hours, round to the nearest whole nautical mile. So there's a drawing that will help us, but I still want to draw it. We've got the plane going south 32 degrees west, and I already drew it west, but so south told me down, west told me to the left, and it's 32 degrees, which has to be this angle. And we know that the speed is 320 knots. I don't know the abbreviation. And we want to find how many knots south and how many knots west. And it's such a common question. Oh, we have to find first how far they go in 1.2 hours. So since knots is nautical miles per hour, we don't have to change units. We're just going to go 320 times 1.2 hours. And this is knots, nautical miles per hour. So the hours divide out and we get 320 times 1.2. We get 384 knots for our hypotenuse. So to see how far south he goes, or she, we want to find this vertical distance. And I'm going to use the convention, always. The lower angle is A, the upper angle is B, the right angle is C. So we know B, that means that the vertical distance is little a, the horizontal distance is little b, and I only know the hypotenuse. So the easiest way to find little a and little b from angle B's point of view is to do sine and cosine. The sine of B is opposite over hypotenuse. Well, opposite is little b, hypotenuse is c. I can multiply both sides by c since I'm trying to find little b. So c times the sine of angle B is little b. And now I can fill in the numbers that we have. We know that little c is 384 and angle B is 32 degrees. So I've got 32 sine is 0.5299. The fifth digit is a 1, so the 9th, I don't have to worry about rounding, but I do have to turn off that number and plug in the rounded one. 59244.5299 times 384. And we get that little b is approximately 203 point, was it 1 decimal place? Oh, to the nearest whole mile. So since this first digit is a 4, it's less than 5, so I leave it there. So B, the horizontal distance, or the distance west, is approximately 203 nautical miles. To find the distance south, we're going to take the cosine. So we know that the cosine of angle B, well, cosine is adjacent over opposite over hypotenuse. Adjacent with respect to B is side A. Hypotenuse is always C. I'm going to multiply both sides by C. So I get C times the cosine of angle B is side A. And now I can fill in the numbers. 384 times the cosine of 32 degrees. So 32 cosine. I get 0.848, and the fifth digit is a 4, it's less than 5, so I leave the 0 alone. And then I have to type in this new number, 0.848, I don't need a 0, times 384. And we get that 8 is approximately. Since I need to round to the nearest nautical mile, I'm going to let this 6 bump the 5 up to a 6. So it'll be 326 knots. And then I'm going to try to be really good. The nautical, the distance south is 203 knots. West. Yes. But I want y'all to remember that we can take something that is at an angle, like this bearing for north, for the flight, and break it into horizontal and vertical components by using sine and cosine. So to get the vertical component, we multiply the angle we knew, we multiplied the distance we knew times the hypotenuse. And to find the horizontal component, we multiplied the distance we knew times the sine of the angle. So sine for horizontal, cosine for vertical, if the angle is in the top here.
Miss Snell? Yeah. We have 1 minute left.
Oh, okay. We have just finished this material, so I'm going to make a page in Canvas for y'all to enter your work for the try thises. And I'm going to take away some of them. I don't want you to have to do 7, but I want you to do the try thises. What do you think is a reasonable due date? What is today? Wednesday?
Wednesday.
Let's say Saturday.
Saturday of this week or next week? Which one are you?
Is that all right?
It's this Saturday?
Yeah.
Okay.
All right.
Okay, great.
All right. Bye.
All right, thanks.
Miss Snell, I might have a question after this. After the recording.
Okay.
Bye, Miss Nell.
Bye. Thank you, Lynette.
You're welcome.